Okay, so we have done already electric charge, and we have seen that current itself is defined as the amount of charge flowing per unit time. So the amount of charge flowing per unit time. Now coming to current, we need to understand certain terminology. The first terminology is the potential difference. So what exactly is potential difference? Now, potential difference is the amount of work done to move unit positive charge, unit positive charge, which means your V is equal to amount of work you do on a charge. So your V is nothing but the potential difference, W is the work you are doing, and this is the charge. Now the question is, when you move the unit positive charge from one point to another, so from one point to another, this is very important for us, one point to another, because it speaks about difference. Okay, so let us say we take an example of a cell. So if you look at the cell, so basically a cell will have two ends, one is your positive and one is your negative. What does it mean? It means it has excess of electron and it has deficit of electron. So here the negative charges are more, and here the positive charges are more or negative charges are less. So here negative charges are more and here negative charges are less. Charges are less. So what we have to do now is we have to see and understand what is the difference between these two. So let us use another color here. So if I connect my cell like this, and if I use a bulb here, this is a bulb, and then I connect it like this, this end where all the negative charges are more, technically your electron will start flowing like this. Now the work that you do here is much less and the work that you do here is much more. Why? Because this electron has to travel all the way till here, you see. So that is the reason why we call the negative end as your low potential. This end is called your low potential, and this end is called your higher potential. Higher potential. Okay. Now current direction, though electrons flow from negative to positive, the direction of current, is taken as positive to negative, positive to negative. This is very important. Now this path that you see here is not the actual path, right? So this path is also known as your conventional current. Conventional current. So what do you understand by this? We understand that if there is a piece of wire somewhere here, if there is a piece of wire, this is a piece of wire, let's say, okay, and one electron has to travel through this. So if the electron direction is this side, then the current direction is this side, I. So this means the direction of current is opposite to direction of charge, okay. So that's the main difference there. Now that is about potential difference. Now coming, what is resistance again? So if you want to know what is resistance, another term now, and that is called here resistance. So resistance is technically, if you have that piece of wire, the same piece of wire, you know, just now what I was showing up, if you have this piece of wire, and if the electron has to pass through this, it is not an easy thing. Why it is not an easy thing? Because inside this there will be a lot of positive and negative charges, So the electron cannot pass very easily, right? So the electron will stop and then again go, stop and then again pass. So that is how it goes out. So it is not easy for an electron to pass through a conductor. That's very important, okay? And lot of work has to be done. So work has to be done. And who does the work? The cell does the work. To push the electron. Okay? So it's not easy for the electron to pass. But then this resistance, so this opposing force that the electron is experiencing inside is known as your resistance. Okay. Now what are the factors that can affect resistance? Also we can see here. So if you look at the factors that can affect, so if you look at the factor affecting resistance of conductor, then we will see that there are some very special relations. One is the length. So if length increases, then the resistance also increases. Right? It's very obvious thing that if you have a very small wire and if you have the same diameter but then long wire, then from here to here your resistance increases. See? Resistance increases. Why? Because the electron has to travel a long distance now here. Okay? Another one here is, it depends on the area of cross section. What do we mean by area of cross section now? We mean that, okay, one wire is having this and another wire is having this diameter. So there is a difference in the thickness here. You see, the thickness here is this much, whereas the thickness here is this much. So in this case, the electron can escape or travel easier compared to thinner conductor. So this means your resistance is less. Because the electron is not being stopped. It can go a little more easily here. So the resistance is less. Okay. So if you have a thin wire, the resistance is high because there is very less space here to escape. All right. Coming to the third aspect, it also depends on temperature of conductor. So if the temperature increases, then the resistance also increases. Why does it happen now? We have to understand. So let's say there is a piece of wire again, okay, and this piece of wire here, and then you have another piece of wire. Both have same diameter, okay, d. Here also diameter is d. But this one is at say 10 degrees Celsius and this one is at 40 degrees Celsius. So what will happen is, here also there are electrons, here also there are electrons, but these electrons will vibrate here and there. They will keep moving fast. So the electrons oscillate or vibrate more due to high temperature. Now because of this, what happens? Temperature. So the free electron cannot pass easily. Because if something is moving very fast inside, then this electron cannot go, right? It is not easy for him to go, okay? So it increases. So that is these are the three factors that affect the resistance of a wire. All right. Now coming to next part of this. This is known as your Ohm's law. So if I talk about Ohm's law now, Ohm's law, what Ohm's found is that the potential difference, which is also known as your voltage, right, is equal to IR. What does it mean? It simply means as V, the volt, increases, the I, which is your current, also increases. Therefore, your V is directly proportional to current. This means directly proportional. Okay. Now, therefore, what is your resistance then from that formula? It is V upon I. So, your resistance is V upon I. And unit of this is volts, unit of this is ampere, and unit of R is your ohms. Okay, or ohms. Now, coming to simple circuits, let's talk about simple circuits. So, if we talk of simple circuit, and let's say you have a cell, this is the symbol of a cell, okay, and the cell is 6 volt. So, any cell which is like this is positive, this is negative. Or if you draw like this, then this is positive, this is negative. So the positive end is shown as long one always, and the negative end is shown as a short one. This is the symbol, okay, symbol of cell. So if I connect like this, and then if I connect to a bulb here, then I know his V should be equal to IR, okay. If the resistance is, for example, 10 ohms, and by the way, the ohms that you see here symbol is for resistance, 10 ohms, then from this circuit I can find out the I, because I will be V upon R, and your V is given as 6, your R is given as 10. So in this circuit your current is 0.6 ampere, okay, ampere. So sometimes ampere is shown as A, but this is positive, this is negative, so your direction of current will always be from positive negative, always, okay. What is the direction of electron then? Electron is negative to positive, but your current direction is positive negative, okay, they are reversing each other. Now coming to types of circuit, let us now discuss the types of circuit, okay. So types of circuit. So basically there are two types of circuit. One is called your series circuit and one is called your parallel circuit, okay. What's the difference between these two circuits now? That we have to see. Let's understand. In series circuit, what happens? So in series, we connect the resistors like this. So this is the symbol of resistor, symbol for resistor, okay. And in this case, if I take this the first resistor, this is the second resistor, then the total resistance R is equal to R1 plus R2. So let us do one example. Let's say one example. If this is 2 ohms and if this is 5 ohms, then I can write R is equal to 2 plus 5, which is very simple, 7 ohms. Okay. Now what happens in parallel circuit? Let us see. So in parallel circuit, in parallel, the same resistors, they become like this, R1, R2. So when they become like this, you see here there's a junction here. There's a junction here. In the first case, the current which is coming here will remain same everywhere. So here the current remains same. Current is same. Okay. Here current is not same. Here current is divided. Why it is divided? Because there is a junction. And what happens when there is a junction? There are two or more path for current. That is why. And this is your junction. So I will label it in using a different color so that it's easy to identify. And this one is your junction. Okay. Now let us try one example. Let's say this one is, for example, say 3 ohms and this one is 6 ohms. And the formula here is 1 by R equal to 1 by R1 plus 1 by R2. This is the actual formula. Okay. And if I go down a little bit, then I can solve this question as 1 by R equal to 1 by 3 plus 1 by 6, which means my LCM is 6, so it is 2 plus 1, which is 3 upon 6, which is 1 upon 2. Therefore, R upon 1 is equal to 2 upon 1, which clearly indicates, shows that my R is 2 ohms. Okay, that's the answer. Now, once I know this as my total resistance, this is my total resistance, I can also find the total current. How can I find the total current? That is equal to V by R. What is the total voltage here? That is your, let's say we connect it to a circuit. So we will put a circuit here. All right. And let's say we supplied here voltage of 20 volt. 20 volt. So in that case, a volt is 20, your resistance is 2, the current is 10 ampere. Right? Note, what do we note? We have to remember here certain things. One of the thing is that in series, the current is constant, but the potential difference which means voltage is divided. Okay. In parallel, the potential difference which is your voltage is constant, but current is divided. Okay. Now let us do some question here and then we will understand. So let's say we solve a circuit here. So we give you 2 ohms and then we give you 3 ohms and then we give you 6 ohms. And then we tell you that this is connected with a cell 12 volt. So what can we do with this question now? Let's see. What's the direction of the current first? We have to see that. This is positive and this is negative. So direction of the current is from positive, like this, like this, like this. You have to solve parallel first. Solve parallel first. So how do you solve? 1 by R is equal to 1 by 3 plus 1 by 6, which means your R is 2 ohms, which you have done now. Now the circuit becomes, I have 2 ohms, and now they have combined to become 2 ohms. See, you have combined them. So you are actually having a series now. So your total resistance will be now 2 plus 2, which is 4 ohms. So this is your total resistance, right? So if somebody will say, okay, find out the total current in the circuit. Very simple. Then what is the total current in the circuit? That will be total voltage by total resistance. So that is 12 by 4, which means it is 3 ampere, right? Now, these are the simple questions that we have in electric circuit. And if there is some logical thing that you want to really think about, one of the logical thing can be that what is the difference between two circuits in terms of reliability. Okay, so in series, if one bulb gets fused, the remaining will also not work. Why? Because in series, if you see here like this, like this, like this, correct? So if for some reason this is not working, then it is just like as if your circuit has become something like this, and then you have only this. So your R1, R2, R3. So only R2 and R3 is working. R2 and R3. And the circuit here is broken. So it will not work. But that doesn't happen in parallel. Why? Let us see. In parallel, what happens here? Okay, in parallel. So in parallel, even if one bulb gets fused, remaining of them work. And why does it happen that way? That happens because if I have my bulb here R1, and if I have R2, and then if I have my source here like this, for some reason this is not working, still I am going to have a circuit which will be something like this. See, R2. So here broken. So this will work. So R2 still works. Okay, and that has a path here for the current to flow. So these are the path of the current to flow. Make sense? So this was about your current, electricity, and the circuit that you have studied. So just remember, for recall purpose, that you have to remember certain things here. So what did you study now in this one? You studied about the potential difference, which is the voltage measured in volts or V. Then you also saw resistance, which was your R equal to V upon I, and the unit is ohms or the symbol. Then you saw series and parallel circuit, and then you also saw the Ohm's law. So these are the basic fundamental ideas that you have to understand to solve the numericals in your circuits, electrical circuit. Okay, and just remember that there will always be energy loss. So energy loss can always happen happen due to resistance. Okay, so thank you.